welcome back to D.Machine. Here on this channel, we explore the remarkable world of heavy industry, where simple materials are transformed into the tools that shape our daily lives. Today, we take a closer look at one of the oldest and most dependable tools ever made, the shovel. From farming and construction to mining and disaster rescue, shovels have stood beside workers for thousands of years. And behind every sturdy blade is a precise, time-tested manufacturing process. In this video, we'll follow a Chinese factory as it turns raw steel into thousands of durable shovel heads each day. Let's begin the journey. As the day begins inside this small Chinese factory, the very first step in making a shovel starts far before any shaping or forging. Large coils of manganese steel arrive on open-bed trucks, heavy, cold-rolled strips that will eventually become the blade of the shovel. Manganese steel is chosen for its toughness. It's a hard, springy alloy that can withstand constant digging, impacts, and years of abuse in the soil. The coils are unloaded and mounted onto a simple, uncoiling stand. As the steel unwinds, it flattens into a clean, bright ribbon. From here, workers feed the strip toward a shear machine. This old mechanical cutter has just one job: slicing the long steel coil into manageable rectangular pieces. Each cut sheet is the foundation of a future shovel head. Smooth, uniform, and perfectly sized, these steel blanks mark the true beginning of the manufacturing process. Before long, each one will be heated, pressed, and shaped into the iconic form we all recognize. Once the steel sheets are cut to size, each one is carried to a heavy mechanical punch press. This old cast iron machine may look simple, but it performs one of the most important steps in shovel making, cutting the blank into its precise outline. Workers position each sheet by hand, aligning it with the die set beneath the press. When the press cycles, a powerful downward stroke slices through the manganese steel with a clean, ringing snap. The die cuts out the distinctive profile of a shovel head, edges, corners, and all the small details that will later be folded or reinforced. These flat, carefully punched pieces may not look like shovel blades yet, but every curve and cut is now locked in. From here on, the steel will begin its transformation from a simple sheet into a tool built to survive years of hard, unforgiving work. Now the flat steel blanks enter the most dramatic stage of the entire process. Each piece is placed onto a moving conveyor that feeds it slowly into a roaring furnace. Inside, the temperature climbs high enough to turn the manganese steel a bright, glowing orange. At this heat, the metal becomes softer and far more willing to take on its new shape. Workers pull the heated blanks from the furnace using long tongs, just like blacksmiths have done for centuries. But instead of a hammer and anvil, a massive industrial press is waiting. In a single heavy stroke, the press forces the softened steel into a forming die, creating the familiar curved shape of a shovel blade. Another die stamps the brand mark directly into the hot metal, leaving a permanent imprint that won't wear away with time. A series of final strikes shape the neck and angle where the handle will connect, giving the shovel both its strength and its leverage. When the red-hot piece drops onto the cooling tray, you can already recognize it. This is no longer a flat sheet. It's the beginning of a real shovel, forged by heat, pressure, and decades-old machinery still doing its job day after day. After forging, the shovel blade is still extremely hot and structurally unstable. To give it the toughness and durability expected from a real working tool, each piece undergoes heat treatment. The red-hot blades are lifted and lowered into a molten salt bath, a traditional and highly effective method of quenching steel. The salt distributes heat evenly across the metal, preventing warping and significantly increasing wear resistance, flexibility, and overall strength. As the glowing metal sinks below the surface, steam rises instantly. The rapid cooling locks the forged shape in place and hardens the blade, so it can withstand years of digging through roots, gravel, clay, and frozen ground. Once the salt quench is complete, the blades are moved into a water tank for rinsing. This wash removes remaining salt and cools the steel to room temperature. What emerges is a fully hardened shovel head, stronger, stiffer, and far more resilient than the flat sheet it once was. With the blade now hardened and fully shaped, the next task is preparing the socket, the part that will hold the wooden handle. Every hole, every strike, every detail matters, because a tool is only as strong as the joint that holds it together. Even after forging and heat treating, the shovel blades are still covered in scale, hard, brittle oxidation left behind by the furnace. To remove it, the factory uses a large rotating drum. Dozens of raw shovel heads are loaded into the chamber. Once the heavy door is sealed, the drum begins to turn. For the next 10 to 12 hours, the blades roll and tumble against thousands of small steel pellets. This constant friction strips away oxidation, evens out rough surfaces, and polishes the hardened metal without damaging its strength. The process is slow, but incredibly effective. When the door finally opens, the transformation is obvious. The dull, dark, heat-stained metal has been replaced with a clean, bright metallic finish, smooth enough for painting, coating, or further finishing. With the surface cleaned and polished from tumbling, the shovel now enters the finishing stage, where sharpness, durability, and appearance truly come together. A worker presses each blade against a high-speed grinding wheel. Sparks fly as the outer edge is shaped into a clean, smooth cutting surface. This step removes any remaining roughness and creates the bevel that helps a shovel bite into soil, gravel, or packed dirt. Next, the blade is passed through an induction heating unit. This machine heats the edge in just a few seconds, hardening the cutting line even further. The discoloration you see, bands of blue and gold, is a signature sign of properly tempered steel. After heat treatment, the edge is cooled and given a final polish. Side by side, the improvement is clear. Before grinding, the blade is dull and uneven. Afterward, the metal is bright, smooth, and razor clean along the bottom edge, ready for real work. This final shaping stage ensures the shovel won't bend, dull, or chip easily, even under years of heavy use. After grinding and hardening, the shovel head is strong, but it still needs protection from rust, moisture, and years of outdoor use. That's where the finishing line begins. Each blade is hung on a moving rail system and carried slowly toward a coating station. Instead of spray paint, this factory uses a dipping method. The shovel heads are lowered into a thick oil-based coating that flows evenly across the entire surface. This layer seals the steel, prevents corrosion, and gives the shovel its deep, glossy finish. As the line moves forward, the wet blades drip gently, allowing excess paint to fall away. They then enter a heated drying zone, where warm air, kept at around 105 degrees Celsius, cures the coating into a hard, durable shell. Once the finish has fully set, workers inspect each shovel, attach labels, and prepare them for packaging. Neatly stacked, tied, and tagged, the blades are now ready for shipping. From raw steel coil to a fully protected tool head, every step ensures the shovel will survive mud, rain, snow, and years of hard labor. From raw steel coils to polished, hardened, and fully protected shovel blades, every step in this factory reflects a blend of tradition, craftsmanship, and rugged industrial engineering. These tools may look simple, but each one carries hours of heat, pressure, and human skill, ready to serve on farms, construction sites, and homes around the world. If you enjoyed this behind-the-scenes look at manufacturing, make sure to like this video, subscribe to D.Machine, and join us as we explore more incredible processes from the world of heavy industry.